Now we're going to continue and derive the differential equation for the RLC parallel. And so for that, the common variable is going to be v of t instead of I. And then we're going to use KCL here. So let's see here, I had negative IS plus V over R plus IL plus IC equals 0. And we know that the current through a capacitor is the voltage times 1 over C here. So actually, sorry, C times V prime. And then we're going to take the derivative of both sides, rearrange things like we did earlier. And we'd have what? V prime over R plus IL prime plus CV double prime equals IS prime. And we know that the derivative of the current is 1 over L times the voltage for an inductor. It's IS prime here. And so rearranging, dividing by C, we'd have V double prime plus 1 over RC V prime plus 1 over LC V equals 1 over C IS prime. And this would be your standard differential equation you would use for any RLC parallel circuit. Now I want to point out a couple of quick things here. First off is these middle coefficients here. Those are actually the reciprocal of the different time constants from chapter 7, right? One time constant was RC, the other was L over R, and these are exactly the two reciprocals. Kind of an interesting note there. Also, both of them have the same coefficient here, 1 over LC. And that is going to have a physical interpretation in the circuit, which we will see in chapter 14. I'll say it right now, but it may not make sense. That is the dealing with the resonant frequency here for this. Okay, and so one last thing to point out is everything in chapter 8, we are going to be dealing with DC inputs, and if you have that, what's really great is then the derivative of it is going to be 0. So all of these are going to have a 0 on the right hand side. They're going to be what are called homogeneous differential equations. So it's really convenient there. Anyway, so now that we have the two standard differential equations, we're going to go ahead and start looking at how we solve these differential equations, and then we'll do some examples.